hate it.
All right.
Oh my gosh.
So, just to pick up where we left off last lesson, we'll get to that sheet in a second. So, oh dear. So, I've been using the language inverse functions, and I've been almost always correct. But that last one isn't a function, is it?
No, it's relation.
How do I know it's a relation?
Because the sideways parabola.
And what about the equation tells me that it's a relation and not a function?
Wait, where are we?
Say again?
Is it a sideways parabola?
It is a sideways parabola, and it's a full parabola as opposed to a half one, and it's the plus minus that's the problem,
How do
right?
you identify a sideways parabola?
If it's root x, basically. Root x is a sideways parabola. So like root x plus 7 is shifted to the left 7 units.
Squared, it's not.
No,
So that's a 7.
it's a line.
Because x squared is.
Well, it depends on other stuff, yeah. Okay, but importantly we know that that one there, when I take the inverse of a parabola, I actually don't get a function. It's still an inverse, but it's not a function. And that's a problem, right? Because that means, the fact that it's not a function means a single input can have two outputs. The whole point of an inverse is to get back to where you started from, right? And you don't know. So later this lesson we're going to be thinking about how to fix that problem. That's not hard. Okay, but first we're going to do graphical. So far we've seen that to do this, we just swap the x's and y's, right? So what about graphically?
The x values go to the y.
This is the second lesson of inverse functions, is it not?
Same day though.
Oh my god. So, unsurprisingly, we again just swap the x's and y's, right? And there's like a visual way to do that. And the mechanism is that you actually just reflect in the line y equals x. So what that means, yeah, I know.
Hey.
So what that means is this is now my mirror, right? So, for example, if I just pick on some numbers,
Yeah, can you plot some? Like.
if I pick on this one here, this has x equals 0, y equals 3. So that will reflect to y equals 0, x equals 3. So that will go there. Okay? And the way that works is you go straight through the mirror, like that.
Oh, wait, yeah.
Okay? We pick another point. So I'll pick...
Wait, what? Yeah. What's the red dotted line?
that is the line y equals x.
We just pick the other one. Why are you having that? I think that's like the mirror.
This bit here, right? So we could pick any other point we like. We'll pick the other intercept because it has a nice whole number. So we've got x equals minus 3, y equals 0. So that switches to x equals 0, y equals minus 3. So that goes down here. Again, we're reflecting through the mirror. It's a straight line, so we join them up. Close enough.
That's a nice example. Thank you for that.
Okay, and so that is the inverse there. No, it hasn't asked for that. We could do it, so we could say x equals y plus 3. So y equals x minus 3, and that would be the inverse function, but that hasn't asked us to, so we don't need to necessarily. Okay, all I want us to be able to do in this lesson is to draw, not to algebraically do it. Okay? Everyone comfortable with the mechanism and all that? We always do, Scarlett. It's okay. We're not moving on yet. So, here's the next one. So this is a slightly different line. It's a line again, but importantly it passes through the line y equals x. So if a point's on the line y equals x and I reflect it in the line y equals x, what's going to happen to the point?
Same.
Nothing. That's the same, right? And if you think about it, if we're on the line y equals x, that means that x and y are the same. So if I switch x and y, they're still the same. So switching the coordinates does nothing, right? Which is why it's the same. And then you pick any other point, or if you're visually inclined, you just say, well, there's a mirror, and I'm going to reflect it in the mirror. Okay? but I'll do the points. So if x equals 2, y equals 0, so y equals 2, x equals 0 is another point. This one here, x equals 0, y equals minus 4, so now x equals minus 4, y equals 0. Now I've got 3 points to try and join up. That's about as good as I'm ever going to manage. But importantly, can you see the symmetry?
Kind of. Do I have to keep going beyond?
No. You mean like this stuff here?
Yeah.
No, it's not a big deal.
But you literally draw the graph and then you
Draw the line y equals x, and you reflect it. Yep.
So y equals a half.
So try and do the next one. Okay, don't worry too much about it looking perfect.
If we know what's going to happen, can we just kind of like...
You should just be drawing it, basically, at this point. So you should just be basically going... something like what I've got there.
Oh, wow. Is it just like the upside down parabola? No.
Not really. It's like it's a sideways cubic is what it is, kind of.
Oh, no, that one, the next one.
Oh, no. Can be sideways.
I'm confused.
Why?
Oh. How did you know that though?
What do you mean?
How do you know it looks like that?
I reflected it in the red line.
Oh, it's like. So would we lose marks if it wasn't that accurate? Like you got the shape and you were like.
Mine's not perfect.
Yeah. I'm just confused how you knew that that's what it was like reflected in the red line. So what does the red line do to it?
That is what we reflect around, right? So one way to imagine it, if you want, is you do it on paper. You draw your graph, and you draw the line y equals x, and then you fold the paper on the line y equals x, and wherever it then lands is where it should end up being. But it's not as easy as like the negative ones. But you just, as you look around, you kind of go, well, up here, you kind of peel away from the line y equals x. So again, I peel away from the line y equals x, right?
Yeah.
Same over here.
Can you just plot the points?
You can plot a few points and know the general shape. Yeah. And that's actually what I'm going to do for the next one.
How do you know what's above the red dotted line?
Well, if it was below and then it gets reflected in it, it's going to be above it, isn't it? So it's like you're like folding it over.
So like this.
Yes. So you imagine your paper is folding over the line y equals x. So for this one, I've got my 2 points where it's y equals x. I know it's a sideways parabola just by experience, but what's something I should probably be thinking about actually getting fairly accurate? The x-intercept would be good, and also the vertex, right? So x equals 0, y equals minus 4, so that goes to x equals minus 4, y equals 0. So that goes to here.
Wait, what was that one, sorry?
That was the vertex, goes there.
So the vertex is just forward, negative 1.
Yeah. And then we can do the same. The x-intercepts were 2 and minus 2. So now the y-intercepts are going to be 2 and minus 2. And then we can draw our best attempt at a parabola.
This makes the most sense out of any graph.
How did you know it was a sideways parabola?
Because we did it algebraically earlier.
So you just knew that?
Yeah.
Oh, because we had the equation.
Yeah. But no, at the very end of the last lesson, right?
Yeah.
We did the inverse of a parabola,
Yeah.
and we got a sideways parabola.
But how did you get? Oh, the inverse of parabola is a sideways parabola. Like I just did this, and then you just did all the opposite.
Okay. So for the first one, that's a function, isn't it?
They're all. That's true.
Why do you need to be a function?
Pass the vertical line.
Vertical line test, right? Second one, is that a function?
Yeah.
The inverse? Third one?
Yeah.
Fourth one?
No.
No. Right, we fail. Anywhere really,
Is
but
it
there.
asking us if the inverse, but like, how would we know if it was asking us the inverse or just the original?
It'll be clear from the wording, right?
Like this isn't, right? Like that's wrong. If it just says the fourth.
That's right. So the first three are functions. Why? Say again?
But they cross those two lines, or are you just doing the new line?
Just the new line.
Just the new one.
Just the
Yep, just the new one. So the inverse for the first three are functions. They pass the vertical line. Laura?
Can you, like, are they inverse? When you're saying whether they're functions or not, you're talking about the inverse.
Yes, I'm just talking about the
Okay, so
inverse.
it doesn't matter, there's no relationship with the first one, the originals and the inverse.
There is, we're getting there. Yeah. Don't say sorry. So the fourth one isn't. Why? Well, it fails.
Failed vertical.
So take a minute and try and work out what do we need to be able to say about the original function. Please don't call out the answer if you work it out. To be able to confidently say that the inverse will also be a function.
Not the.
Shh.
Deeply confused about the reflected line.
Caitlin?
Needs to be a one-to-one function. Doesn't need to be one-to-one.
It does need to be one-to-one. What does that mean?
Horizontal line.
It means you pass both the horizontal and the vertical line. Because the idea is, the reason this one fails the vertical line test there is because that is actually this horizontal line reflected. Right? So if you fail a horizontal line test, that's going to reflect into failing a vertical line test. So Caitlin has the language right. A function has an inverse, and I don't think this is on your sheet. You need to transition now into your notebook. A function has an inverse if it passes both the vertical and the horizontal line tests.
So technically the last one doesn't have an inverse.
It does not.
So what would
That's
you
why
call
it's not
that we've
reflected.
just kind of made?
An inverse relation.
Is that why it
Do we
doesn't
use that as
reflect?
topic, or is that
No.
Is that why it's not reflecting like equally on the line? Oh, it is. Fine.
Okay, such functions are called one-to-one, and one-to-one means 1x goes to 1y. And that's important.
So they all have to be one.
Yeah, the whole thing has to be one-to-one. Because if 1x goes to 2y's, then those 2y's are going to try and go back to 1x, and that doesn't work. That's not a function then, right? But importantly, what we're going to do is if a function is not invertible, meaning it doesn't have an inverse, we're going to restrict its domain to make it so that it does. Okay? So, if I look back at the example that just failed, what is a domain for the original function which makes it pass both the vertical and the horizontal line test? So restricted to name. Yeah, that is an example. So if I just said x is greater than 0 or equal to,
or x is less than 0?
that will be the yellow stuff there only, right? And can we all see that that passes the vertical and the horizontal line test? And if I invert it, I just get this, which is a function. It passes the vertical line test, right?
So to make a thing.
Or you could have done this one, which would invert to this,
So
which is also a function. There's normally more than one option.
So it's like an open house.
So you make like you say the domain and then they got like 0.
Yeah. So normally we're interested in the largest possible domain.
Is it always just going to be 0 to
No.
So what do I write down for that?
Yeah.
Functions that aren't invertible can be made to be restricted.
What did it say?
Restrict the domain to make a function.
Functions that are what?
Just it's literally a function.
It's written right there.
I'm not having a philosophical moment. I'm just reading it.
So if you're not invertible, you can restrict the domain to make it so that it is.
But why are we calling it functions? Isn't it a relation?
Well, we always start with functions,
Okay.
and the point is that we want the inverse to also be a function. We actually don't like relations because they're not as predictable, basically. There's not as much certainty.
Wouldn't, if you look at the
Mathematicians
first
thrive
example,
on certainty.
If you look at the parabola,
Yeah.
when you look at the mirror line, isn't it gonna work like beyond the bottom of the parabola and that little bit that's like green?
No, because then you end up in this little section here, and you've doubled back. So then you draw a vertical line and you fail.
So you could do x is smaller.
So on the axis. That's good.
It's on the turning point,
Can you write them both?
which happens to be on the
Chuck
axis.
a comma in between.
Normally, you would be asked the largest domain containing the number blah.
Largest.
Yeah, largest domain. Because there's infinitely many domains. Like you could say x is greater than pi or something stupid like that, right? But you want the largest domain, and normally you want the largest domain that contains a certain number,
So it
so that there's only one answer.
starts / ends on the turning
Zoom in
point.
a bit, I can't really read it.
So genuinely,
Genuinely.
generally, you're doing x is larger than or equal to 0.
No, not 0, but
Or just like
a number,
that
yes.
X is larger than.
So with this restricting the domain, it gives us two somewhat separate lines, which we can then call an
Invertible function, that's right.
But usually you're only going to
They
be asked to graph one.
We're going to do some examples
It
in a minute.
crosses the line twice. At the
Wait, is that homework?
here.
Is that homework?
What?
Doesn't it cross like twice? See if I was doing the vertical line just now. Yeah, if I was doing the vertical line just now. Crosses twice.
Yeah, but that's because
But the bottom's gone.
I am so confused.
You don't include the original function.
you're equal to original. Okay.
Ah.
So
Yeah.
Oh, okay, yeah. Okay, so in not too long, I'll let you loose, and that is some of what you should do. Okay. So we talked about this morning the inverse function notation. If you haven't already written that down, please do. Importantly, it is not 1 on fx, right? They are different things, okay? That is important. And the domain and range of an inverse function. So if fx is 1 to 1, so that means it has an inverse, and the domain is from A up to B, and the range is from FA up to FB, then the domain of the inverse is the range of the original, and the range of the inverse is the domain of the original. So you just switch, right? That's just basically a really fancy, complicated way of saying all the x's become all the y's, and all the y's become all the x's, right? We swap all the x's with all the y's. It's just a formal way of saying that.
So can you just like if it says find the domain and range of the function,
Yeah.
find the domain and range of the original, and then swap the numbers.
Yeah. Okay, so it's all really just about swapping x's and y's in every possible context, I suppose.
So the domain and range switch.
Yes. Domain goes to range, range goes to domain, basically. Nah.
I don't understand how to reflect on that line.
So if I did that just on pink, it would pass the test.
Yes.
Then I did just on red,
Yeah.
it passed it.
Did you get that? I don't know how to graph it because I don't have any plans, but if I did, I would graph it.
So, let's just start with something. Let's do something slightly different.
Should we always draw the y equals x? Should we always draw that thing?
Yes. Yes.
Yeah, it's so trippy.
So
It takes me
basically,
so long to that.
like previously, we've done like you do this and then you flip it over there, right?
Yeah.
And you flip that over there. So you just kind of switch it that way. You're doing the same thing, except you have to tilt your head to the side. So all of this goes down to there, and all of that goes up to here.
Can we just plot the points?
So you can plot points, but this bit here gets reflected there. So it's going to do something like, we're going to turn into a love heart kind of shape. There, right? Because this bit is being pasted across there.
You're gonna watch me flipping my page in the exam.
You should.
Like ridiculous.
But then aren't you only plotting half of it?
Okay?
Where's the other half of it gone?
He hasn't done it yet.
Oh.
It shouldn't have folded over quite so much there, right?
So it's probably the other way.
Yeah.
Because it's a.
At the end of the day, like you shouldn't draw it the way it is. You just go, oh, it's so much better, right?
Yeah. Or we plot points.
Yeah, I would plot the vertex and the intersection, right?
Yeah.
And make sure you go through at the same spot.
Then what was that thing you were saying about like highlighting?
Oh, so then I'll just
So I was saying that if you take the restricted version to be that, and then you
So,
convert it
what video
into
is the best one,
that,
anybody?
it's
X gonna
basically-
be
Be like,
and range y and then
All right. So let's find the domain and range of a function. How do I do that? Draw it. Yep. Oh god. So what does that look like?
hyperbole.
Hyperbole. And I say hyperbola.
Hyperbola? Isn't that a English reference?
But it's the same, it's basically based on the same thing. It's called a hyperbola because it goes to infinity. So where are the asymptotes for this one?
2 and 0. Like 0 on the X.
So domain x is not 2, range y is not 0. So I could already answer C, and I could say the domain is y is not, sorry, x is not 0, range is x is not, that's, range is y is not 2. So I'm just doing that, right? But I'll do it the way they want me to. So find the inverse, swap your x's and your y's.
Yeah.
So for a hyperbola, is the range always y not even 0?
It's whatever the intercept is. This one's not. The inverse isn't, because that's shifted down to.
What are you doing with me?
I'm finding the inverse.
Oh, okay.
Is it just going to be like in the negative?
I think it should be 1 on x plus 2.
Over here.
It's always someone, Daisy.
It's not really far out. What did I do now? You missed it.
So I got
You missed my mistake.
Or it is plus 2.
Thank you. I appreciate it. So there's my asymptote.
shifted up to.
So everything's shifted up to, which is why y cannot equal 2.
Oh, we have to do it. That's what that asks us to
You're much more polite than Tara. You said, I think.
do. So would.
Not, it's wrong.
So that's but that's always going to be function to pass.
Say again.
Like the inverse of every function is like a hyperbola will always pass through.
Don't whittle it down, Daisy. Just say it like it is.
Yeah. How did you get B? I got minus x minus 1.
Like in maths tests and all.
Say again.
How did you get?
Exactly.
How did you get to that? You just did the flipping thing.
Yep. Well, actually, I multiplied by y minus 2 and I divided by x, but it's the same as flipping.
So when they ask you to find the inverse, you immediately have to go x equals and then go from there.
Yeah, switch the letters, yeah.
What's the point? Because like you have y in the beginning. Joke.
That,
Trying to find the inverse.
graphing hyperbolas.
I like it. No, I'm not a fan.
I don't get how you
How I drew it,
Yeah.
it's a hyperbola up 2 units. 1 over x plus 2.
So far away.
I didn't reflect it. I could have, but I didn't.
So I had gold public holiday.
Alright, I don't like this.
Well,
My
it was like
family's so
crying or getting falling on the floor. And then going home. Caitlin goes to
Getting.
You go home, and Caitlin vanishes.
No, Caitlin just goes off to the south coast and lives there for like 6 months and like, resurrects and
Hmm?
the passes out.
Resurrects down the mountain.
All right.
My brain had already flipped it.
Restrict the domain of these functions to find an inverse function and find its domain and range. So for the first one, it's a parabola, just a standard one. So you need to basically find the largest domain, which will pass both the vertical and the horizontal line test. So the easiest option for that is just positive x values. Right? It will pass vertical and horizontal. I did.
Oh, I do. That's really helpful.
But don't you do that for all domain and range?
Yeah.
Okay. So the domain is x greater than 0. Range is also x greater than 0. So that's true for the inverse as well.
But isn't the range?
But what does that end up looking
No,
like?
you don't need the range.
Yeah.
Oh, we just restricting the domain. Oh,
Yeah.
no, losing it.
But the range can be negative as well.
Yeah.
So I've ended up with just this.
Isn't range minus infinity plus infinity?
Not after we restrict it.
Or have we already restricted?
So I've restricted it to the red. So when I reflect it, so that's f. So this one here is f inverse.
So you just said that it has to be bigger than 0.
Yes.
So the other one's just gonna be the same, just because it happened.
No.
That looks like? That looks like a square.
No, why isn't it?
Square. Rooted.
Oh yeah, it does look very
Yeah,
No,
it's because
why
it is.
isn't
It is.
Oh, 'cause
If-
it's taking it to
So y equals x squared. Take the inverse, right? X equals y squared. Y equals x.
But isn't it
I thought one of the rules was like, it's not like this.
So would you draw the asymptote?
You lied to us.
Would you draw the asymptote for one now, or no?
Yeah, what's going on? Now I'm confused.
You can if you want
I
to.
wanted to know, but what I was saying is the domain and range is set. Like they just.
What's
So,
happened?
how would you know any points to plot? Would you just not plot the point?
You don't need to for this one, right? It's just asking you for the domain of the function, giving it an inverse. So you just a domain that makes it 1 to 1.
Okay.
Can you do the just to the other side?
Yes.
Just to the other side.
Yep.
Wait,
Do
is
you
it
like my
x is less?
Two different answers, yeah.
Wouldn't it be
I'm having
x
a lot of
is
fun
less than or
decorating
equal to
this.
0?
Normally, if we can pick the positives, we do. But technically, you wouldn't be wrong, right?
X is on that side. The blue is on that side.
Say that again.
The blue is on that side.
Yep. But I've restricted it to just the red bit, right? I chose x greater than or equal to 0.
What's the point of
But
that?
you can choose, in this example, you can choose either. But normally, I would say something like, which includes x equals 1 or something, right?
So you change the domain and the range. Because when you say restrict the domain, do you have to restrict the range as well?
Restricting the domain can restrict the range, yes.
It does.
Not in this example, no. The range is still positive anyway. But in most examples it would, just not parabolas. Let's do the next one and we might understand it a bit better because this one's got a bit more going on, right? So
A -4.
x squared minus 4x. So that goes through 0 and 4, right?
Oh, thank God. What else not? Why is it not what I got? Oh, I should have that.
So there's two options for restricting the domain.
Do the positive.
Right? You can either do the yellow bit,
So there's Loki and asymptote.
So we can't do vertex?
or the blue. We will have to work out the vertex, yeah.
2 minus
2 and, yep, -4, yep. Okay, so let's pick the yellow one because it's just normally what we do is we take it to the right.
So go to
So for F, the domain and the range are what?
up to 2.
X is larger than or equal than 2, and Y is larger than or equal than 2 minus 4.
And so that means that for F inverse, the domain is X is larger than or equal to -4, and the range is Y is larger than or equal to 2. So we literally just switch, right? That's all we ever do. X becomes Y and Y becomes X.
Radio. Amazing.
So I'm getting confused between this and like
Here looks like square root. Thanks.
So then do you
So
use that to draw Sideways parabola?
You could. It doesn't actually ask you to draw it, so you don't have
so
to.
when how can you draw it? Sorry.
So you draw Y equals X.
Yeah. Oh, do you have to draw it?
Oh, you would just like draw.
And then you reflect the points.
So that's
So
gonna look like a
4 is going to go to 4. And then it's going to go through 2 minus 4. So it's going to look something like that.
What's the point of the
Oh,
Y?
pretend I...
So if
What's happening?
so if it's a parabola, so basically if it's not a cubic or a straight line, you should pretty much restrict the domain.
Yes. If it's got a turning point, you restrict it.
How do you know where
Well,
it
cubics
stops?
technically kind of
Oh,
Doesn't
where it
stop.
stops. That's stupid.
Oh yeah, it stops at the vertex. Yeah.
Sorry. What?
That's cool.
Is F is the blue one, right? So isn't
No, F is the yellow one.
I thought F
That's why I've highlighted them both yellow.
is that the F the yellow minus?
Sorry, I see the confusion.
Okay, that makes sense.
It's just like so much.
Is that the inverse for yellow?
Yes. We did everything there for the yellow one.
What the hell is that asking?
What?
That
We're not up to that yet.
So she's like, let's give her name would be
Do you believe it?
Okay. Last thing. So we've got fx.
fun for you.
We've got fx equals 2x minus 5.
Vietnam.
And we find the inverse by switching.
What's the question asking? What does that even mean?
he's just proving to us.
So it's just asking you basically to find the inverse, right? I've done that so far. And then I've just got to prove this little rule about inverse functions that says if you do the function and then the inverse, or you do the inverse and then the function, you get back to x.
So is that just kind of saying like even functions?
Not really.
Wait, so
Not really.
do you make that function up?
Okay.
Recording it for.
Nikki.
Oh my god.
Oh,
So
No, she's gonna, yeah, no, go like, no, it's getting in me. She's gonna come for me.
You might have got away with it if you hadn't like kept going on about it. She might not have heard the first bit.
Well, it's over
$50.
now.
I'll edit out this segment if I
$50
like.
so she'll top it off.
35.
Can you make my voice like monotone?
I would put
so
$50
she doesn't know
on
who I
that.
am?
What do you mean make it monotone?
No, like make it like a Siri voice, so there's like no tone in my voice.
Yeah,
How like
make it-
murderers,
yeah.
how like murderers use that when they like send in like voice memos.
Yeah.
Like,
Like, can you explain like that?
I got a few murderer friends.
Hey?
Oh, you're just stating what the
Yeah,
inverse
just
comes
cut
out.
it out.
Yep. So I've just found the inverse and now I'm just playing with the function notation. So f inverse of fx, I replace fx with that, and then I put 2x minus 5 in over here. So it's 2 bracket x plus 5 over 2, oops,
I'm really
minus 5.
What?
I'm really
No,
confused.
Why
no.
keep the 2 at the front?
Sorry, did it wrong. 2x minus 5
I don't even know how you
plus
got
5 over 2. So I put the,
What? I think you like missed
I hate
it.
this. You
I
missed
kind
it.
of understand.
so where it says x,
Nikki, help us.
Nikki.
I wrote 2x plus minus 5.
You didn't know who she was like 2 minutes
Don't talk about my best friend like that. Me and Nikki are tired. It's an inside joke. It's an inside joke. I love you,
Can you
Nick.
put this on
I am putting it on YouTube. They always go on YouTube. I'm going to put it as my promoted video on my channel.
The Nikki
I
Chronicles.
understand.
Nikki is an icon.
So first we found the negative thing.
I'm really confused. Am
I
I meant to know how to do this? Or can I just accept the rule?
You can accept the
I don't
rule.
even know.
I don't understand how this is
Oh,
using. Sorry.
Forget it, you just sub in.
What? I don't. I need to know.
Are you just subbing in the X value?
No, I understand how to get the inverse. I found the inverse.
Yeah.
That's where I ended.
What does that have anything to do with showing that blah blah blah?
He's
blah, blah?
proving.
It's just a way to reinforce the fact that this is true. Whoops, it's not a highlighter anymore. That this is true. That if you take a function and then it's inverse, you get back to where you
Do I
started.
need to know how to do that? Or do I just have to accept that that's
Well,
fine?
what did you write at the start?
You might have to be asked to do it. Yeah.
What? I don't understand it though. So you're gonna
You're subbing in the
I'm
X
using
value.
function notation, right? So I'll do the other one and talk it through.
Wait, what do you mean we'll be asked to do it?
I said you could be asked to do
So
it.
f of
We
negative
will be
1.
asked.
So f of f inverse of x, right? So start from the inside and go out. So instead of f inverse of x, write all of this.
Oh, I actually can't understand.
So x. What's x?
It's a letter in the alphabet. Like, what do you mean?
Thank you.
But it's just like a.
You know that shirt? There's like triangle on it.
It's just a thing.
You're putting f. What's f function? Like,
Yeah, f is function.
of the negative one that we found before.
Yeah.
It
Equals
is a letter in the alphabet.
function of what?
Okay,
Of the negative
does
one.
this help? Read that.
Thank
Right?
you.
No.
Read it.
Hey, Caitlin,
See how-
read it.
See
I help?
I've written here.
help.
See how I've written here in 3 lines. These 3 lines translate to that.
Thanks, Bella.
No, just read it and you'll get it. Just promise.
I got the first half now.
So what this says now, right,
I'm still really
is so I'm going back to f back here, and I'm saying where I see.
Y, F's annoying.
Shh, shh, shh. I have to use f. Where I see x, write this.
But you're writing the negative.
So,
that's not
2
the original.
bracket x plus 5 over 2,
Oi, why are we doing it a different way?
because it asks you to do it both ways.
Oh.
No, go another one.
Why does it ask us to do it both ways?
Wait, did you read this?
Oh, we don't. Why is that necessary?
I'm so I'm literally so lost.
Okay. It might be better for me to come and sit with you individually, I think. Okay.
Do you think you'll get more sensible than I just don't know this video?
Unlikely.
Oh, you can just subbing it in.
Don't worry.
Alright, bye Nikki.
This